All right, so welcome everyone. Thanks for being here with us today. Hopefully we'll learn more about Dask and then DataFrames and then how can we use them better and then learn some best practices. We have all the material on this GitHub repository. So if you haven't gone through setup and stuff, go ahead and click in there. There's a binder button, so then you can follow along without needing to install things locally. By the way, my name is Nati Clementi, and I'm a software engineer at Coiled. You can find me on socials if you want to, or GitHub, anywhere with this handle. So let's get started. We do have, like, as we mentioned before, like the tutorials materials are on this GitHub repository, and then you should have received an email invitation from us to be able to launch clusters under the Dask tutorials team, and then you will be able to log into like cloud.coiled.io. So let's get to it. So what's Dask first? Like in a quick overview, Dask in general provides like multi-core and distributed parallel execution on larger than memory data sets. You can think of the API as a low level and high level. And a little bit of context, like high level will be high level will be things that are like ready to use. So for example, if you're familiarized with Pandas, then the Dask DataFrames are going to be that kind of like equivalent that you will be familiarized with. And then like the operations will be pretty much the same. Today, we're going to concentrate on learning one of these high level collections called Dask DataFrames. If you're interested in knowing how to manipulate more like low-level collections like futures, then we do have another tutorial that concentrates on Dask and then gives you a little more granularity on what to do with Dask. You can sign up in the tutorials page, and the same way that you sign up for this one will be available the other one. So now let's get to the content. So I am going to probably make this bigger because it might be small for folks. And today, as I mentioned, we're going to be concentrated on Dask DataFrames. And Dask DataFrames looks and feels like the Pandas API, but they are for parallel and distributed workflows. The idea is just to get better at this. Is like going from serial code to a distributed code can be challenging, and then we are trying to kind of like give you some tools so then you can learn about that. Now, when we have like big data frames, a big amount of data, then we do have challenges. And then there are like a couple of things that we can do when we use Dask to kind of improve our experience and then get better at data frames. So one of the things that is worth mentioning is that you can think of a Dask data frame as like multiple Pandas data frames. And then like they're kind of like going to be partitioned in different pieces that individually are a Pandas data frame. And then the workers are going to be kind of processing these ones in parallel. So when we're working with distributed data frames, we have like this like Dask data frames that now are like kind of chunk up in multiple pieces. And then we're working with big data, probably on a cluster. There are like other things that we need to take into account. For example, one of the things that it's important when you're working on a cluster, like in the cloud, is if your data is stored in an S3 bucket, let's say, that is like far away, and I'm speaking like far away, even like physically, like far away from your cluster, then like the networking and the IO network is going to have a high impact. So those are one of the things to consider. And you will see that along the way, when we are creating some clusters, we are going to have like the data, creating the clusters closer to the data. And in this particular case, it's going to be the US East 2 region. Just some other things to take into account is like the format of the data the format that we store the data in. Most of you might be familiarized with CSV files, and CSV files have been around for a long time. But when it comes to big data, CSV files can be like really like low performing. So one of the most performing is like data files that we use is like Parquet, and Parquet files are something that are very optimized to be able to read like data, and they're like compressed. So one of the beauties about Parquet is like they're column oriented, meaning that like if you see like here on the plot, like the data will be in a row oriented, it will be kind of like oriented like A1, B1, C1, but on a column oriented, we'll have like all the A's first and then all the B's and all the C's. So the advantages of like the Parquet data format is like being column oriented, have like better compression and improves performance. And they are designed to efficiently store and retrieve data. So for example, we will have the advantage of having column pruning, which means like we are going to be reading just the columns that we need. Like when you're like selecting the columns, you're not bringing everything into memory. As I mentioned before, we have like better compression, and because each column data types are fairly similar, like compression is easier to get. And the other important thing is like we have an schema. Like in CSV, for example, you don't have an schema, and then you need to either be you need to supply the schema, or the schema needs to be inferred. Supplying a schema is tedious, is that you will have to kind of like really think about, okay, what are my data types, how this behaves. And then inferring a schema is usually like error prone. So if you have CSV files, like usually converting them to Parquet will like kind of leads to a better experience to you. And then just as a motivation example, and then we're going to launch like our first cluster right now. What we're going to see is like, for example, when we do have data in CSV, stored in CSV and compared to Parquet, like how that behaves. So let's get our first cluster launch. We're going to get a cluster that is more or less like a beefy cluster, because we're going to continue later on processing data that is big data. So it's not that you need this side of cluster to perform the operation that we're going to do right now, but we will need it like later on. So one of the things to mention is you should have, like as I mentioned before, receive an email from us inviting you to join the Dask tutorials team. So to be able to log in and then into that account, especially if like you haven't logged in like locally yet, but like on Binder, you will need to grab a token. So we're going to go, and I'm going to show you like here. So if you are over here, you should be on the Dask tutorials team. And then on the top right, you should see your profile picture, or like an avatar or something you put. You're going to hit on profile. And then you are going to get a token. So here you will create an API token. So you're going to click on there. Then you can label here like Dask tutorial, and I'm going to call it just test, because I will delete this one immediately after. You can create it. So you'll create there, and then you will get a token here. I want you to copy that token, and you will paste that token right in there, and then uncomment this line. Quick disclaimer, if you are running things from a Windows machine, you will need to run this command from a PowerShell or like a git bash prompt. It won't work from the notebook. So just bear in mind, like you'll need to go to a terminal, then type this, and then follow along. We want you to log in on the Dask tutorials account. So then like add this after the token, you just need to like get this, make sure that you have that. So I'm already logged in and set up. So I am going to avoid this step, but please do that. If you have any problems, let us know in the chat. I'm going to import like the libraries that I need to get this. We are going to create quickly like just an ID clusters. This is like just a unique identifier for each of us, because we're all going to be on the same team, and then we don't want to be clashing into each other's. So we're going to get that. So I see a question that says, how do we get to Dask tutorial account again when we are logged in? All right, yes. So on the left, you should be here, and you should have Dask tutorials in there. If you follow along the instructions to get added to the tutorials team, you should have received an email, and then you should be on the team. When you create a token, it doesn't necessarily matter where you are. Like as soon as you just get a token, and then you will like add the dash account here in this part of the login. Great question. Thanks for asking. So we're going to have like this unique identifier because we are all going to be using that same team account. So then like we don't want to like be reusing our clusters if we name them the same way. So here's how we launch a cluster. I'm going to be requesting 10 workers. This is going to be the name. I'm getting a little bit ahead on what we're going to do. So I'm calling this like the New York City over Lyft. And then the ID, this is the cluster that we're going to use. And it's under the Dask accounts. And as I mentioned before, like we want to be close to the data we're going to be working on with. So then here is this region set. So we're going to get this going. This should take about like a minute and a half. As you can see here, we have like a nice widget that is telling us what is happening. So it's provisioning the instances, and it's kind of like looking for the package that we need. And there. So it says, just a heads up, there is a question. It says, my bundle requests timeout 3 times while waiting 30 minutes. I got a local copy working, but just for awareness. Interesting. I wonder if like maybe there are like too many people like using Binder or something is happening. Right before the tutorial started, I was able to kind of get it going in less than 10 minutes. But thank you for that. We're going to look into that. Maybe there's something that we can do to make that lighter. So as you can see here, like we are downloading the environment, and then Coiled is like smart enough to kind of recognize what are the packages that we have installed locally, and then it's replicating those packages in the cluster, in the scheduler and the workers. So then as soon as you have your local environment kind of clean, let's say, then Coiled will just kind of like replicate that, and then like you won't have any issues, and then you don't have to worry about syncing packages. So we got all our workers, and then now we're going to connect our client. So connecting the client, then you will see here that we have the dashboard. So I am going to put the dashboard on the side. In the meantime, we do have maybe making it a little smaller, so then we can see there. There is a Dask Live extension. Like at the moment, the button it's not currently working, but we're working on fixing that. Otherwise, it'll take a little bit of getting things set up. But we do have our client. We have connected. We have our clusters. You should all see your clusters in here. In the dashboard, I see like I have my cluster there, and then there are like other clusters over here. So then that's nice to see. You can find yours in here looking by the ID, or you can actually check which one is your username. So let's get to some stuff. One of the things that I wanted to show you first was like how important it is to kind of like probably work in the Parquet world compared to CSV. If you don't have an option, you don't have an option. But like when you do, here's what's happened. So here we have like 2 data sets that are, one is on CSV and the other one is on Parquet. And then I'm going to read both separately, and then I'm going to do the same computation, and then we're going to see what happens. So this is just like data from a benchmark, so it's like not that relevant. I want you to notice something over in here. In the CSV file, in the CSV data, we have all this ID 1, 2, and 3 showing as objects. These are strings, but show us objects. And then this is something that it will eat up our memory because of the data type. And then there are like the flow 64 and the in64s that are over there. Now, in the Parquet one, like you have the possibility of having this as categories, which in some cases help. So in this case, for ID1, ID2 will help, for ID3, probably not. But then we can also kind of do other stuff to work with this data. But just as a reference, just only moving to Parquet. Now, if we do, let's time the two different computations. So one will be the CSV one. I'm doing a simple aggregation, like a group by ID1, and then aggregating here. Let's get the dashboard nicer in there. And it took like about 7 seconds. Now, we do the same in Parquet. And then it took us like a 1.5 seconds. So immediately you see some speed up. I'm using the same cluster and stuff. Then you can see like that improvement. So one thing that you might wonder, okay, what's happening? And then, well, we can take a look at the memory usage. And then that's something that probably is going to help us understand this a little bit more. So this is a way of checking at the memory usage of one partition. So you just grab this, use memory usage deep through, compute, and then like we're applying like a Dask function to make this more human readable. So you can see here that these ones are like, okay, 50 to 60 megabytes, and then these ones are 7-ish. Now, when we do the Parquet one, you will see that these ones are significantly smaller. It's like almost 60 times smaller. And this one, as I mentioned, is not necessarily the case, but like there is an impact in the rest of all the other ones. So like keep in mind that like when you're working with Parquet, it's like you will get advantages by converting to Parquet. So now we have seen this play with a little bit of data. Let's just go to a big example where we have like big data and we want to process things, and then problems that you will encounter like in the wild or maybe at your work and you probably have. So today we're going to be working mostly with the Lyft New York City dataset. This is the high volume for hire services. So you might have worked before like with the New York City taxi one. This one is like another data set that is similar to that, but it contains like pretty much Uber, Lyft, and then other app services here. So you can get the dictionary and know more about the data. There's all the links out there. Just to kind of take a look, this is a way of inspecting the kind of files that we have there. So then we can see that all the files have this kind of look. There is some sort of date that looks like a month, and then there is a .parquet in there. So, and we will have, like in this case, 48 files. So the cluster that we got before, it's a cluster that we're going to be working with. It's a big enough cluster to be able to kind of explore this data. So we're going to be reading this Parquet data. If you are running things from Binder, you will need to add this line, so uncomment things, and then run that line. As you can see, like here, there's not much that had happened because like up to the point we haven't like, we just only have a laser representation of the data frame. So as it says here, like there are 48 partitions, and we see that we have like all this like columns, and you see there are objects and date times and float 64s. So let's take a look a little bit at the data, the D types. So you see, like we have this object stuff, and we learned from before that having objects is a little bit bad. Okay, I get a message that says, I get the following error for inspecting data running locally. No credentials error. You shouldn't need credentials to run, to be able to inspect the files. This is a public data set. I'm not sure, maybe James, you might know something. It's part of that code that is inspecting the glob. James, if you have like any ideas on what we can happen with S3FS and can assist on the chat, that will be great.
Yeah, we'll do.
Cool.
Looks like multiple people got it.
Interesting. Maybe something changed in S3FS or something is happening there, but yeah, if you can take a look, that would be great. we can check like what the memory footprint of this looks like, and by just checking a one partition, and then you will see that this is going to take a while. And this is something that it's interesting, because what happened is like, even though they have like multiple partitions and then they're using Parquet, each of these partitions are massive. Like you will see, you're seeing here on the right, let's see if I can make this bigger. You're seeing here on the right that that the bytes are going like, they're going like way up, like it's like 8 gigabytes. So it's kind of, there we go. You can see here that is that we're up to 8 gigabytes, which is like a lot for a one partition. And there's like only one worker doing job, because we just grab only one partition. So it's like, it's trying to process this, and it's like, okay, done it. And it took like 49 seconds just to take a look at only one partition, which is like a lot. So you can see here, like we're having like 550 megabytes, which is not that big. But then we have like other columns that are like 1 gig, another gig, another gig. Again, like we have both of that. So these partitions are big. And these, yeah, these are like, it's kind of like a problem, because it's that this is a challenge that you will have, and you get big partitions and you have like kind of inefficient data type. So we can work with that, and then we can actually modify things to be able to process this. So one of the things to notice is a partition size is a hard kind of topic, because like you can have, it depends on the partition size, things are going to change. As a rule of thumb, a good point to start exploring when you're like about to repartition things is to have around 100 megabytes per partition. That's what we've seen that more or less work best, like as a rule of thumb, but it will be dependent on your problem. Definitely 8 gig partitions are not a good thing. So what we want to do is, what we recommend is like repartition about like 100 megabytes. And then other things that are useful to do is inspect the data types. And whenever you have object types and they are strings, you want to be using string by arrows. And this will actually optimize the memory usage. And then you want to check also that your integers and floats, if you don't need 64, then you can use 32. And sometimes categorical data types might be useful, might be not. It depends on the cardinality of your column. So one thing that we're going to be doing first is we're going to create a conversions dictionary to convert the D type. And then to do that conversion, like as I say, we're going to convert the objects to string by arrows, the floats, and in64 to 32, and then see how that behaves. So that's the dictionary. I'm going to cast this conversions and persist that data. So this is going to take a little bit of time because these data frames are like big. Seeing that we still have a lot of questions about when a big data frame is read, is the data distributed and stored on the Dask workers for subsequent run? All right, so the question is, let me rephrase that. When a big data frame is read, is the data distributed and stored on the Dask workers for subsequent runs? Okay, so when we do the read CSV call, like, for example, like up here, up to this moment, nothing has happened yet. This is like a lazy evaluation. So then it's kind of like creating a graph, and then it's ready to send things out when needed. Now, by sending it to the workers, it's like when we are reading it, it's not sending nothing yet. Now, if we persist the data frame, which is currently what I'm doing, what it's doing is persisting it in memory. So then that way it's going to be like quickly accessible to that. But for that, you need to have like a lot of memory to be able to work with. In this case, I have a big cluster, and because of what we're doing, it's in there in memory. Now, if not, like if we don't persist, what will happen is when we trigger a compute call, like the one that we have here, then the scheduler will send the task to a worker or to multiple workers, and it's going to be like sending those tasks. As part of those tasks, it's going to get like a piece of that data frame, like a partition to work with. So yeah, it's like pretty much the scheduler is the one that is distributing the work and is doing those connections and sending them to the worker. When we persist, we keep things in memory. So then that makes like things eventually go faster. But for that, you need the memory availability, which in this case we have, and we chose that on purpose because of this data frame. So if we can see now, like now that we converted the data types, let's see what's the memory usage now. So when we converted memory, now remember that we have like 1 gig partitions and things like that. Now we do have, just by converting the data types, we have like a way less memory being used by each of these columns. Like before we have, I remember that we have a couple of these ones being 1 gig. So for example, the web request flag was 1 gigabyte and then now is 20 megabytes. So all of these are like a kind of good practice and taking a look and then see what we need, and then also be nicer on the cluster, especially if like you're needing, like you don't have that many resources. The other thing that we said that we would do is we still have these partitions that are big. So then we're going to repartition the data frame. So then we have pretty much every partition is about 128 megabytes. So I'm going to do that. I'm going to persist. And this is going to happen fast because like the other data frame was like already persisted. So if we take a look now at the memory, like of each of these, in total, I have like 82 gigabytes. Right at the beginning, I forgot to mention that, but at the beginning, this data set had like about like over 200 gigabytes of memory usage. I see a question. It says, can we persist data between computes in other places like Redis S3? Oh, you mean, okay, only a memory of the Dask workers? Okay, so if I understand correct the questions, you are asking if we can persist or save the data in S3 in intermediate step. That will be writing it to S3, but then like when you read that, it will be like an IO, like network transfer, right? Like you will be reading it as if you were reading it from other places. We're going to do something like that, like in a couple of minutes. But like when we are talking about persisting in this case is I need to go through my data. I need to do some changes and stuff. If I have the memory, I can bring that data like in memory. So then like the computations will happen like kind of much faster. I am not sure what Redis is, but I'm happy to comment. I'm happy to read about it later on and then maybe comment in a future session. Does that answer your question? I'm gonna like follow along until I wait until we see more questions. But right now we'll see that like after we repartitions, we have 720 partitions. Before we have like way more, and that was kind of like a lot. So now every partition, like if we check the memory, it's going to be about 100 megabytes. And this makes sense because we just repartition to be this way. So there are other ways of repartitioning, and not only by memory size. Like you could have an application where you know that you need the data to be partitioned by day. And then, for example, you could actually set an index, which will be the request date time in this case, and then you could repartition by day. Now, bear in mind that sometimes like the amount of data for a day could be really small. So then your partitions can be really small. So even though that is something that you need, then you will have a lot of like network transfers, and then maybe partitioning in such a small size won't be convenient. So that there are trade-offs, and depends on what your application is. Like you could partition by day or by week, depends on like if you have a request like a daytime index. So now we got to a stage where we do have our data that is much smaller. It's still same data, but it's like a smaller, like the data types are like kind of better. We discover that, we repartition. a natural thing to do will be saving this step somewhere that I can work with if I come back later on, or my colleagues need to do some work with this data. So what we're going to do right now is we are going to save this data into an S3 bucket. So I will give you right now some credentials to a bucket that you will be able to write. And then later on, I will remove those credentials after the tutorial. But here, I would like you to kind of copy. I'm going to paste it in the chat. So you should be able to copy literally that instead of this. So I'm just going to comment this out. And you will have these credentials there. And then I want you to put your name here or something that reference you. In my case, I'm just going to put Natty. And we are going to now write that data set that we just kind of clean up and then make it nice into an S3 bucket. So here we need to provide the storage options. So then we're going to do a write Parquet. And here we go. So now we're writing. And as you see, we're writing to Parquet. You should all be able to write to that bucket. Just make sure, put your name, don't put mine, because then we're going to overwrite each other's data. And the beauty of this is we can actually now move on into a cluster that is much smaller. We don't need such a big cluster in terms of memory and all the resources. This is something that you want to think about. When you've done the hardcore work, then you want to move into something probably smaller to optimize costs, and then or you can just change the size of your cluster and then play around with that. So we're going to shut down this cluster now, and then we're going to be reading the data set again. So I know that some of you have some trouble creating this data set. Don't worry about it. We do have a public one that you should all be able to read, and this one we control, so then you should be able to read this data set with no problem. So if you got stuck up to this point, I apologize for that. We're going to look into trying to make that that experience better. But to move on now, you can kind of come back, and we're going to read now, create a new cluster. As I mentioned before, now we don't need those R6i 2x large. Now our data set is smaller. We have less lamemory pressure. So then we are going to kind of get this type of instances, and we're going to get 15 workers. So let's launch another cluster. You know the drill already. I'm going to close this guy here. In the meantime, you'll see here we have the new ones. They are scaling, and then eventually here on the left, you could access the dashboard from here too. If you want to inspect other stuff about your cluster, and I'll use the sign while this cluster is scaling, you can always click on your cluster, and then you will get eventually when things show up, you will get some metrics and logs. Because I am kind of admin on the team, I can see, for example, what Philips is doing, and then I can see some metrics here, and then what's the CPU usage. And then if you need logs because you have some problem, you can kind of check on the logs over here and then see what's happening on the workers. You see there's some instructions in there. So then that's a nice thing. So you get details. So you get to see what's queued, what's starting. And then if there was an error or things happened, then the cluster will be ready. And yeah, here you have the task. And then there are some code. For example, here, the CSV partitions that we run. Then you get to see that. So we're going to go back to the dashboard, and then just kind of taking a look here. My workers are ready in a minute and a half, and now we're going to connect the client. So then now I'm going to get the link to the new one. Just going to put it in here, and as I said, now we're going to read back that data that we just saved. So if you have problems creating your own data set and then write into S3 as we did, then instead of this line over here, replace it with what it's here. That should be the same data set, and you should be able to play with that, and then you should have no trouble. And here, if you were able to write to S3, then this will be the file that we're going to read. And now what we're doing here is currently there's like no round tripping to read back a string pi arrows like in a straightforward way. There's like work happening on that, and eventually that problem will happen by default. But in the meantime, like those strings are going to be read as objects probably, or like Python strings, depends on the situation. And now with the new Pandas 2.0 and things coming up, then this process is going to get much easier. But in the meantime, there are like 3 columns that we know that there are strings, and we do want to read them as pi arrow strings to kind of like have low memory usage. So that this is how we do it. So we do that, and then we're going to now check the D types, and you see that here it says a string, but I am sure these are string pi arrows. You can actually check the D type specifically of that column, and then you'll see here that it's a string pi arrow. I'm not going to run this competition again, but we know that our whole data set is about 80 gigabytes. We just want to take a look quickly at what do we have here. We just don't remember what we had before. We do have this HVFHS license numbers and things like that. These are like related to if it's Uber, Lyft, Via, and then other one that I don't remember the name now, but we're going to be exploring those. Same in Pandas, like if you see this like very familiar like to the Pandas API, you can check the columns, and then you have that. If you want to check the length of the data frame, like we can, this will actually bring the whole thing into memory, and then like you will just like be computing like the length of the whole data frame. It's about 700 million rows. So it's like a good amount of rows. Like we're gonna get to play with that. So now, for example, if we want to see, and this is like probably not the smarter way of doing stuff, but it's something that people do, and you can still do it like in Dask, which is like, let's just count what's the number of elements that I have on each column. And then that way I can see like, hey, do I have nones or not? And then what's happening with my data. So you'll see here, we're going over the whole data frame. And then at this moment, I'm computing things. And the data frame is not in memory. So going back to the question that we had before is like, what happened when we read it? Well, at the moment we read, nothing happened yet. And here it's like reading this partition, sending to the worker, doing the computation, bringing back the result to the client, to my notebook. But it's not going to persist anything in memory. You will see that when this finish, the memory footprint, like over here, is going to go back to like pretty much nothing and whatever is on the system. So this takes a little bit. You can see here, like all these tasks, individual tasks are data frame count chunks. So it's like each of these chunks are being sent to the workers, and then workers are processing that. And then you can see that, okay, we do have, for example, this one has, I would say, doesn't have any not numbers because like the numbers are the same. But you can see, for example, the airport fee one has a lot of non-values. And those values are because maybe not, like actually it is because not all of the trips were from the airport. So it makes sense that some of this have not numbers. I see a question, but the partials compute of each partition is stored on the Dask manager. I'm assuming that by Dask manager, are you referring to the scheduler? So are we talking about like the partials in terms of like, we send the task, let's say in this case, we were computing, the scheduler. So we send the task. In this case, we were computing the count. So yes, for example, it depends on the algorithm and it depends on what's the specific case that's happening. But basically what's happening is I send the task to the worker gets a chunk. And in this case, count is something that is kind of easy to parallelize because I can count for that column and that chunk was the value. and then it's using that value, and then it's aggregating all those values. And I'm assuming, and James, please correct me if I'm wrong, because he might know better, is like you get all those values of the aggregation of the partial, kind of send it back to the scheduler, and then aggregate them all together, and then send it back to the client. I do not recall if the scheduler is the one doing the aggregation here, or if it's if all happens like somehow on one of the workers.
It happens on the workers.
It happens on the workers. Okay.
Yeah, the scheduler just coordinates all the tasks, and the workers sort of. So the workers are the place where the actual computations happen, all of them, including the aggregation.
The aggregations. Okay, so then answering the question that is, but the partials compute, each partition is stored in the Dask scheduler, the answer is no. The workers do all the work, and then they do the aggregations, and then like ultimately what we'll get back to the client is like the last result. It says, I have a question that says, can you provide a valid user ID for this line, as I wasn't able to load the initial data? Yes, so instead of that line, comment that line. So the line is this. So I'm going to go back here. So in this case, comment this line or replace this for what it says here in the comment. Use this as the address to pass to the read CSV or the file to read. So you can copy that and replace it for this F string. Good question. So here we just saw that we are going to kind of quickly do some filtering. We want to check which one are the trips that have a tip. And then we are going to only grab some columns that we need to do some data analysis. Like we don't need all the columns. And this is kind of one of the beauties of Parquet. Like I'm going to grab only these columns. It's going to read only this ones. And then this is what I'm going to persist. So and we persist this, and this the persist calls happens in the back. So as you see, this doesn't block my my cell. So then it's happening on the back, and it can continue doing some of the operations. For example, head only uses the first partition. So then it's kind of like you just read this, and then we're able to do it while things happen on the back. So a couple of things that we could do is similarly like in Pandas, you can do some aggregations. The only difference in the syntax is you just need to add compute at the end, because without the compute, this only generates the graph. So we're going to see, for example, what's the compute of the base fare for the trip. So it's like about, I divided by 1 to the 9. So then this is like in billions. So we got like 15 billion dollars. And then let's see what's the driver pay. This is kind of like a comparison to see. It's like about 12 to almost 13 billions. So not that different. Although like drivers have to put up with like the gas and then all the things. But in general, that's kind of like a comparison. And then let's check out the tips. So the tips are like in the order of the 600 million. So it's okay, we were talking about billions, and then now we're talking about millions. So this is interesting because like the tips are less. I do wonder, like one of the things that we could take a look at is how many people tip. Like do you feel bad when you don't tip, or if you tip, like how much do you tip? So let's just try to answer those questions from the data, and then let's take a quick look. So we can do a tip count. So we can group by the provider. And then we can take a look at the tip flag that we created, which was like yes or no, it's like true or false, and do a value count of that and compute. So if we run this, we'll see some action on the dashboard, and that we're doing just the group by, and then we'll quickly see that what's the value there. So let's take a look at what we got. Just for reference, what happens here? Okay, there we go. So we have these codes that are a little bit, they're hard to read. So we know from the data dictionary that 02 is Juno, 03 is Uber, 4 is Via, and 5 is Lyft. So you can see that, okay, out of all the trips, like most people seem to not be tipping compared to, like, if you see the numbers, like the amount of people that tip is way less than the ones that don't. So let's now this tip counts as like a series, so we can actually get it into a little bit of a more readable way. So here is like pure Pandas code so far, nothing different from what you will do in Pandas, and the percentage of the total writes that tip. So then you can take a look at that just to get, it's like another like way of presenting the data. But what we're seeing is, okay, so percentage of total writes that tip is like 10%, 15%, maybe 20%. So to be honest, we just kind of discovered that New Yorkers are not big tippers. I mean, there are not many tippers in New York, it seems, compared to the amount of people that don't tip. So we can aggregate this, but we can get some more data. Here is just a little bit showing how you do some analysis on this. As you see, like we're filtering here. So this log, this is a typical Pandas operation. You can do this too. Then you get the group by, and then you will be able to compute. For some reason, the dashboard seems to be stopped, but there we go. Those were the operations. And I'm going to use this kind of quick dictionary just to kind of map and then present this data in a nicer way. Then you can take a look at this. Oops, I didn't run that one. So this is a little bit nicer. Now we do have this like absurd numbers seen here, because these are like the sum of tips, and then this is like the type. And we see that the amount of tips value is like over and Lyft are higher than the other two, and this is because just like probably they are more known than the other two, or there are more cars. But in general, it seems like everyone tips around $5 when they tip. So this is like not that crazy. It's some numbers that we would expect. We want to see probably what percentage of the fare is a tip. I would expect this is around 20%. It's like people tend to tip 10%, 20%. So again, like the operations are very similar to what you will do in Pandas. So then you will like divide the stuff, and then you get tip percentage. And then so far, as you see, like nothing really has happened in the dashboard yet. Oh, I realized like I said this as an exercise. Well, just show the exercise, but we'll have more exercise to go in. But as you saw, is that I executed this cell and then nothing happens on the dashboard. And this is because so far, like we haven't computed or persisted or done anything with this. So I'm going to persist this so we can add that column into our data. And then we can take a look at this and then see, for example, now what's the tip percentage by provider? Similar operation that we did before. Now we're just taking a look at we're grouping by the provider. And then if we just want to write this in a nicer way that we can read, we can see that, okay, it's like 20%, 15%, 20%, and something crazy we're seeing here. Uber seems to, oh wait, only people, like when people tip, only tip like 3% of that. That seems strange. So one thing that we can do is take a little bit of a deeper look into the data and then see if this data is dirty in terms of like, we might have so many weird numbers that this is like affecting this. So one thing that you could do is like kind of like get some statistics about like the dollars per mile or like how much money people are paying. And then you immediately start seeing these numbers that is like minus infinite and infinite. So then this tells me that, okay, this data needs to be clean. And we can even filter by the trips that have the tip, same way that we did before. And then you can do like, again, like these aggregations. But this is like something that is still like seems dirty. So kind of like to start looking a little bit more into this, and we're kind of wrapping up here soon, is we can get an insight on this data. Like, you can do the typical describe. This is a little bit of computational expensive, but you will get a little bit more information than what you got here. But one thing that you could do is get to know the data and then try to maybe get a sample of the data and then see what we can do with that. So let's work on that together. We're going to do some plots here. And let's start taking a sample. We can just take a sample of data. So in this case, I'm going to be grabbing 0.1%. So this is going to be like 700,000 rows. And then we can do some plots that can guide us to see maybe what's going on. So here we're taking a sample. And when we take a sample and we do the compute, this df tiny, it is a Pandas data frame. So now we're like in Pandas where we're not like using the cluster like from now on. So when I do this box plot, this is going to be happening in your laptop or in Binder. So you can just execute that. And yes, we do have a lot of outliers. You can see that trip miles based passenger fare and tips have a lot of outliers. So maybe a good idea to get a better understanding of our data will be cleaning those outliers. Now, working with percentiles in a distributed way, it can be tricky, but as a first approach, we could actually get what are the first and the third percentile, like the 25th percentile and the 75th percentile, and then based on that sample, we can filter our full data frame. So you will compute the quintiles in this way, like this is Pandas code. So quick exercise, how would you compute the quintiles for the base passenger fare and the tips? So I'll get like 1 minute. You can kind of copy and paste this and replace the corresponding answer. This should be straightforward if you all are familiarized with Pandas. If you folks don't feel like doing the exercise, you can just like execute the cells that are coming right after. So as I said, like these are quite straightforward. So we get this quantiles values. And then one way of filtering like our data set is creating these filters conditions. And then where we are like kind of using the lower bound of the 25th percentile and the upper bound of the 75th percentile, and then kind of using the between operation to kind of filter those values. So the way that we'll do, for example, the tips condition will be, we'll get a filter that basically is the values that we just computed. And then we use the between here to be able to filter that. The reason why I'm using this asterisk here is values is this is like going to give me like a series like over here, like it will give me like a tuple, that's a word. And then I just need to unpack it to be able to tell between to use the two ends. So then the tips condition will look something like this. We'll have like multiple values, and then we'll have like true and false, and those will help me filter stuff. So another exercise, let's create the filters, these conditions for the other two, for the miles distance and for the, which one is that? The trip miles are for the passenger fare. So give you 1 minute to maybe you can copy and paste the code and then do that. Do we have any questions so far? See many questions. Well, we'll move on. Just like, let's do the first one, kind of like, you can see the first one down here together. Again, like the filtering happens the same way, and then I'm just unpacking those and then using the between operation. So if we run those, we can now probably do the same plot that we did before. What we're going to do is filter the data frame. So now, if you haven't done this, you can provide the conditions as and operations. So you can do those, and then do the box plot of those. So again, like because we're in Pandas world, this should be something that you're familiar with. But now we get like this nice box plots that seem more reasonable than what we had before. Now we do have those numbers that give us like an upper bound and a lower bound to be able to filter the data. So let's apply those to our data frames, and then let's see how the value of the percentage changes now that we have cleaned the data up. So this is the same operation that we did on the DF tiny, but now we're going to do it on the big data frame, on the one that we call it small, the one that has the reduced amount of columns, the ones that we need, but it's still like a big enough that contains like all the 700 million rows. So as you see here, we're using the same conditions. So we're going to do the betweens. So you see, so far, nothing has happened yet. This is like the part where it's the lazy evaluation. And then like, if we compute this now or persist it, then we can take a look at what the value is. And if we do the exact same operation, we can take the dollars per mile now and then compute it. And then now this number seems way more reasonable. It's like the minimum values of this are like about $2 a trip, and then the max is like around 17, and they're all very similar. So now if we do the same operation that we had before, for the sake of time, I'm going to run over this, but like if we do the same operations that we did before, you can see that now pretty much all of them are around 20%. And Uber, which was like around 3%, now is 20%. So this tells me like, yeah, you should probably clean your data. So just setting this in a more readable way, then you get to see the Uber there. That before was giving us like that 3%, now it's 20. So you can take a look at that. And we can do like more aggregations. You can take a look at what's the average trip time by provider. And then like if you want to see it in minutes, then you can see that folks are like traveling between average 20 minutes there on an Uber. Here, there are a couple of values that are lowest range, but there are the maximum values. So probably you can do some more cleaning in there. This is all we got in terms of like playing around with this data set. What do we learn today? Well, most New Yorkers do not tip, but it looks like of those who tips, it's common to tip around 20%. Just always make sure that you clean your data to be able to get like an accurate or more or less accurate representation of the situation. And the trip time columns need probably a little bit more cleaning. And this is kind of like part of the thing. If you want to keep playing around with this data set and with these notebooks, we're going to leave the accounts on the Dask tutorials open for a little bit longer, so then you can spin up some clusters and actually take a look at those and then do it yourself. For now, I'll ask you all to shut down your clusters. And this is like a great pleasure to teach you today about Dask DataFrames and how to get better at them. If you're interested in learning more about DataFrames, there are useful links like the Dask tutorials DataFrames session, which is like a different, and it's just like it's your own pace. And then something that I'll encourage you to do is you all can register for upcoming sessions in coiled.io/tutorials. And the next session will be in 2 weeks. We're going to be learning about how to parallelize your Python code with Dask, and it'll be more on the lower level APIs that we have, and particular features. So thank you very much. If we have any questions, I have some time, and I can stay for a little bit. Okay, someone mentioned I managed to solve the S3 access issue. The New York City requires at least an AWS account. Okay, so you need at least some credentials. Is that like what are we talking about? That's correct. Okay, so that's good to know. Do you need to create an account, or for example, using the credentials that we have at the initial, you can kind of like do export the Any credentials. Okay, great. So we could, for the future, provide the credentials that we give initially to folks, and then like do like an export of the environment variables. Okay, perfect. Thank you. And probably I'm going to mispronounce your name, Ashraf. For this, this was great. It's great to know. I'm going to include this as part of the tutorials, and then I'm going to make sure that then everyone can have a great experience next time. This was very valuable. Okay, we have a question. I have a question that is a bit out of scope. Is there a way with Dask to group by more than one level? In this example, say the mean tip by month and by provider. It's simple with Pandas, but have been stuck in Dask. Can we group by? I shut down my cluster, but I could have tried. So are we saying like group by but more than one thing? Is that the question? Like, let me see. Yeah. By and I'm going to do some Googling thing here. I want to see if in the Dask documentation there are more examples about this. Can we group by? Okay, we can do multiple aggregations. I do wonder if it's possible. Let me, you know what? I bet it is. There might be some caveat. What I would recommend, if you have an example that is failing and you're trying to kind of do, there are a couple of ways of providing a reproducer and then asking for help. So in this documentation, in the group by documentation, you can see how to create a fake data set with Dask dataset time series, and there is like an ID and name, so probably you can do a group by there, and then try to post what you're trying to do, and then post a question on the discourse. We have folks there paying attention and trying to provide help with this stuff, and then we'll try to help you out there. I think it will be very valuable for everyone if you post there, and then we can just have a track on how we will do this. On the top of my head, I do not remember if we can do this. I have the feeling, but yeah, discourse is great. We have the discourse, and then like folks can post like multiple questions, and then you get everyone from the community helping in there. So yeah, that will be great. I will though keep this question. I'm going to see if this is possible. I'm going to try to get some example of this in the tutorial for next time. I'm going to take a look at that and then see if we can do such a thing. All right, folks, this is it for me. Thank you very much for being here and then learning more about Dask. If you have any specific questions about the tutorial itself, feel free to open an issue on the repository, asking questions there, or on Discourse and multiple places. Then we're going to try to answer the best as possible. Have a great rest of the week.